I was recently asked if I could explain how the lava effect was created that I showed in a video the other day. So this is a bit of a rough and ready video to explain that. We will get going. I'm losing my voice, as you can see, so we'll see how this goes. However, just to refresh people, I added a feature to the Voxel editor that would let you import an image, essentially, and use it as a height map. So I generated an overhead view of lava using ChatGPT, which caused a minor bit of discussion, and you can see the previous video from my comments on that. I am a sort of cautious explorer of AI. Is probably the best way to explain it, but I don't want to get bogged down in that here. So we'll just choose that image again. I'm going to resize it a little bit. The height will be related to the height map. You see there's an option here, use the image as a height map. Invert height map, what does that mean? Well, basically, the height map is generated from a perceived brightness of each pixel in the image. And if you invert it, the darker colours will appear higher than the lighter colours. And if it's not inverted, the lighter colours will appear higher. I'm just going to make this a slightly higher model and give us a bigger height. Not that big, that would be a bit silly. And call this Lava 4, and hopefully this will work because this is in development software. Okay, it did work. Hurrah! That's great. Okay, so there's my lava. I didn't invert this one, so the lava is higher as opposed to the one I did the other day where the lava was lower. You can see that's mouse wheel scrolling, and then obviously that's the trackpad for sort of inertial, more elegant and smooth scrolling. Yeah, so that's what you end up with. That's a keyboard rotate, and that's me dragging with the mouse, and I've got a little sort of, you can move into the keyboard or out of the keyboard, and you can actually reposition the camera, various bits and pieces. Anywho, we've got a height map generated, an image of voxels rather, an image of voxels. We've got a voxel landscape generated from an image. So how does that work? Let me shut down the Voxel editor, and I'll go through some code. I should say this code it's from quite a big app, and it's in progress. I've been learning stuff, so it's not the ideal code base to explain this from. Given this is a Mac app, and it also works on the iPad, I'm using the Mac here to show this. It's in Swift. It uses Swift UI and Metal. When I actually release this thing, I'm going to also release some shaders and code that let you import the voxel landscapes into WebGL. I may do something with Vulkan. I'll see how much time I have, but I want to spend some time making the shaders I used here available elsewhere. They're not particularly complicated, but they're worth talking about and sharing so people can use the voxels easily. In any case, hopefully people can now see Xcode. And I've started at the bottom because the real key to this is this function here called perceived luminance. And this is essentially a formula that you can find if you go and look into brightness of colours, how the eye sees colours, that generates a single number representing the brightness of a colour. And it does that by weighting the red, green and blue components. And if you've done a little bit of math, you can see this looks perhaps a little bit is it Pythagorean? Is that the word I'm looking for? I'm just talking my high school maths. I sort of write maths as I do code. I'm not really a maths expert. Sometimes the names of things escapes me, but it's a little bit Pythagorean, and you can do some interesting things with colours by treating them as vectors and getting into kind of vector math with them. Topic for another day. In any case, this returns you a number. The higher the number, the brighter the colour. So given that, once we've got the brightness of the colour, it's actually pretty straightforward to translate that into a voxel landscape. And inside my voxel editor, there are a couple of things that represent the voxel landscape. One is this concept of a voxel sprite, which is a class in Swift, and it has width, height, depth, and it maintains inside it a set of chunks. The actual sort of sprite graphic landscape is broken down into chunks, and there's a couple of reasons for that. One is if you try and represent the voxels in one one sort of buffer for metal and the GPU, you can start blowing the size of buffers and numbers and things. So you kind of have to chunk them for that. And the other reason is performance. I've not really done anything with this yet, but you can kind of throw away whole things from the rendering pipeline based on where they are, how far away they are, and doing that at a level of more than one voxel is quite helpful, because voxels, there tend to be a lot of them rather quickly. If you start multiplying up sort of 512 by 512 by 512, you start ending with very big numbers. So you have to sort of think about memory management a little bit when you're doing this, and how that translates into performance, updating the voxel model, etc. That's a voxel sprite. Inside the voxel sprite, there's these chunks, and it's the chunks that actually contain arrays of voxels. It's actually a sparse array. I think I wrote it some time ago, so they're not always populated. Only populated when we need to be. But in any case, the thing we're interested in here is this initializer, which takes an image, some pixels. Well, it doesn't actually get pixels. It gets a function that gets the pixels and returns a palette entry for them. That's just an RGB. There's some palette work goes on in here. It means I use my own class for that some of the time. And ultimately, once you've got that, the key to generating a height map is just this thing here, where you see color.perceived luminance. I'm not sure why this text is very tiny. Some of it's big, some of it's small. Obviously not configured Xcode properly for presentations. In any case, I'll continue, and if it needs editing later, we can edit it later. In any case, there's the brightness, and then turning it into the range. There's a little bit of twiddling based on if the height map is inverted or not. But essentially all you're doing is saying between the, up until the max range, between the min range and the max range, take that brightness, which is between 0 and 1, multiply the height by that, and that's the number of voxels to kind of count up vertically. We populate those voxels. I have adjusted it for the chunk catcher. I can delete that comment. And then that populates our grid. And once we've populated our grid, that's our sprite populated. And it sort of winds its way back up to the image popover, which is the thing that kicked all that off. So yeah, it's very simple really. It just it generates that terrain using a height map, and it generates a height map from brightness and luminosity. So hopefully that's interesting to people. As I say, will follow up with more on the sort of rendering side of voxels and some of that stuff at a later date. Anyway, hopefully that answers the question I was asked the other day. Thanks a lot.